Touch the wall behind your couch right now. Go ahead. If it's a hot summer afternoon and that wall feels warm, almost like a low-heat blanket pressed against your hand, your house is not protecting you. It is slowly cooking you from the inside. And your air conditioner is just making your electricity bill bleed while it tries to fight back against your own walls. Here's the part that should make you angry. This problem was solved over 200 years ago. Not by engineers, not by scientists, not by any billion-dollar building company. It was solved by farmers who never went to college, never had electricity, and never needed it, because their walls did the work for them. And the solution costs less than a cup of coffee. Stay with me, because in the next few minutes, I'm going to show you exactly what they figured out, why the American building industry quietly buried it, and what you can do about it this weekend. If this is the kind of information you want more of, real practical knowledge that most people will never find, hit that subscribe button right now and drop a like on this video. It genuinely helps more people find this. Now let's get into it. Right now, on a normal July afternoon, the outside surface of a standard American home's wall is absorbing solar heat and reaching temperatures above 150 degrees Fahrenheit. That is not an exaggeration. That is what an infrared thermometer reads on dark or medium-colored siding on a clear afternoon. And here's the part nobody talks about. That heat does not disappear when the sun goes down. Your walls store that thermal energy and slowly dump it back into your living space for hours after sunset. This is why your home feels stuffy at 9 p.m., even though it has been dark for 2 hours. Your air conditioner is not fighting the sun anymore. It is fighting your own walls. The material your walls are made of is the core of the problem. Modern American homes built after the mid-20th century rely on a combination of fiberglass insulation, wood framing, sealed drywall, and synthetic exterior siding. Every single one of those materials was chosen for speed of installation and low upfront manufacturing cost, not for how well it actually manages heat. Fiberglass insulation, which most homeowners assume is doing heavy lifting, actually loses a significant portion of its rated performance when the temperature inside the wall cavity rises above 95 degrees. And it rises above that every single afternoon on any wall facing south or west. So the insulation that is supposed to protect you is essentially on vacation at the exact moment you need it most. Now here is where this gets interesting. There's a community of people living in rural Ohio and Pennsylvania who have never had this problem. Their homes stay remarkably cool in summer without any mechanical cooling system at all. Their heating costs in winter are dramatically lower than comparable homes in the same climate. And they have been building this way, without change, for over 2 centuries. The Amish figured this out not through science experiments or university studies, but through generations of observation and craft knowledge passed down in ledgers, apprenticeships, and community memory. And the core of what they figured out is something called lime plaster, a material that most modern builders have not touched in 30 years. An exterior wall finished with lime plaster behaves completely differently from a wall covered in vinyl siding or acrylic paint. Properly applied lime plaster reflects the majority of incoming solar radiation away from the wall surface entirely, rather than absorbing it. It also releases moisture slowly through a process of evaporation, which cools the wall surface the same way sweat cools your skin on a hot day. Beyond that, lime undergoes a slow chemical process as it cures, where it absorbs carbon dioxide from the air and gradually converts back into a form of natural stone. That process actually draws a small amount of heat out of the wall surface itself. The combined result is a wall that stays dramatically cooler, holds a steadier interior temperature, and lasts far longer than anything built with modern synthetic materials. Studies comparing traditional lime-plastered homes to conventionally built modern homes in the same climate zones have found the lime homes using significantly less energy for both heating and cooling. That research exists. It was published and reviewed. Most people have simply never heard of it because it does not benefit the companies selling vinyl siding, fiberglass insulation, and HVAC systems. Which brings us to the question you're probably already asking. If this works so well, why did it disappear? The answer is frustratingly simple. In the early 1990s, national residential building standards were revised, and lime-based exterior finishes were quietly removed from the recommended materials list. The official reasoning was that lime takes longer to apply and requires more skill than modern alternatives. The real reason is more obvious when you look at the numbers. A properly applied lime plaster coating on an exterior wall can last well over a century with minimal maintenance. The synthetic alternatives last 20 to 30 years before they start peeling, cracking, and trapping moisture, at which point you pay to replace them. That replacement cycle is worth billions of dollars to the companies that manufacture and sell those materials. Lime plaster that lasts your entire lifetime and your children's lifetime is simply bad for that business model. The Amish never received that memo. They do not subscribe to national building industry publications. They kept doing what worked because it worked, and they had no economic incentive to stop. Here is where this becomes directly useful to you. You do not need to tear down your siding. You do not need a contractor, a permit, or even a full weekend. There is a simplified version of lime plaster called lime wash, and it is exactly what it sounds like. Hydrated lime mixed with water until it reaches the consistency of thin milk. You apply it with a wide masonry brush in 2 to 4 thin coats on any porous exterior surface. Brick, stone, stucco, old wood clapboard, concrete, mortar joints. All of these accept lime wash directly with no primer and no surface preparation beyond a basic rinse with a garden hose. A single bag of Type S hydrated lime costs around $5 at any farm supply store or masonry yard. Mix 3 pounds of that lime into 1 gallon of cool water in a bucket. Let it sit overnight. The next morning, add 1 cup of plain skim milk and a 1/4 cup of table salt. Then stir thoroughly. The skim milk is not a folk remedy. The casein protein in milk reacts with the hydrated lime to form a natural binder called calcium caseinate, which dramatically increases how long the coating adheres to the wall surface and how well it resists weather. This exact technique was documented by the United States Department of Agriculture in a survey of Pennsylvania German farm building practices conducted in 1937, and it traces back to practices that were already old when that survey was written. Farmers who added skim milk to their lime wash had exterior coatings that lasted 2.5 to 3 times longer than plain lime wash alone. That document was filed in the National Archives and never appeared in a single modern building manual. The salt serves a different purpose. It slows the drying process slightly, which gives the lime just enough time to penetrate the microscopic pores in the wall surface and lock in. Without it, lime wash can dry too quickly and sit on top of the surface rather than bonding to it. Apply the mixture with a wide, natural bristle masonry brush in thin, even coats. The first coat will look streaky and almost transparent. That is normal. By the third coat, the surface will be a clean, bright, chalky white that reflects solar radiation rather than absorbing it. One important thing before you start: fresh hydrated lime is strongly alkaline and it will irritate or burn skin and eyes on extended contact. Wear rubber gloves, protective eyewear, and a dust mask when you are handling the dry powder. The Amish men who do this work wear gloves, wide-brimmed hats, and eye protection when they are brushing it overhead. Treat the material with respect and it will serve you for decades. On the south-facing wall of a brick home in the Midwest, this application dropped the surface temperature at 3 in the afternoon from nearly 150 degrees to under 90 degrees. A difference of more than 60 degrees at the wall surface. The interior surface of that same wall dropped over 15 degrees within 2 weeks of application, and the summer electric bill dropped by more than half. That is from one wall on one side of one house. If you have vinyl siding, lime wash will not bond directly to it, but you can apply it to any masonry features, the foundation, exposed brick, chimney, or concrete on your home, and still reduce the overall thermal load measurably. If you ever reside, consider leaving a section in a less visible spot for a small test panel of lime wash on cement board. Once you see the surface temperature difference with an infrared thermometer, you will understand exactly why this knowledge was worth burying. The deeper truth here is that your house was not designed to keep you comfortable without expensive mechanical systems. It was designed to be cheap and fast to build and to need replacement components on a regular schedule. That is not cynicism. It is just how the incentives were structured after World War II, when speed and standardization became the dominant values in American construction. The Amish built differently because their incentives were different. They needed their homes to last generations with minimal outside input, minimal cost, and minimal reliance on supply chains they did not control. Those constraints produced better walls, walls that breathe, regulate humidity naturally, resist mold, reflect heat, and last longer than the people who built them. You now have the recipe: a $5 bag of powder, skim milk from your refrigerator, table salt from your pantry, and a Saturday morning. That is the entire material cost for treating the exterior of an average American home with a thermal coating that NASA confirmed the physics of in the 1950s, that the USDA documented in 1937, and that a community of farmers has been using without interruption since before the United States was fully industrialized. Tell me in the comments which wall of your house you are planning to treat first: south, west, or the full exterior. And if you already have original lime plaster anywhere in your home, tell me where you are located and how old the house is. There are more of these details coming. Things about root cellars, thermal mass flooring, and passive cooling systems that have been sitting in farming extension bulletins since the 1920s, waiting for someone to pull them back out. Subscribe so you do not miss what comes next. Share this with someone whose house runs hot every summer. The knowledge exists. It just needed someone to stop pretending it does not.